All right, fam. We are back at it again. Today we're doing number 69, square root x. I'll give myself 1 hour. If I couldn't figure it out, I will consult the answer. All right, let's do it. So, given a non-negative integer x, return the square root of x rounded down to the nearest integer. The returned integer should be non-negative as well. Okay, do not use this, sure. Okay, so let's say if I do this with the built-in exponent, I would do um I would do int our x 0.5, and then I just return this, right? If I were to do this, like, yeah, I think this would work. Okay, but I am not supposed to do this. Um, so what do I do here? Um, my square root. So x times x, and then um, so it done you the input that I'm given, right? Uh-huh. So um I read somewhere I think it's on learncpp.com. Mm, wait, this is not that. Okay. Square root of x as from within or something. Okay, this is not what I need. Okay. I have no clue where to start. Can I get a hint? Exploring all integers. Uh, so for ni equals to 0, I less than, uh, let's say for a really large number, right? And then if I multiplied by I is larger than x, then wait, shit, did I overwrite? Here we go. If this, then I'll return I. Something like that. else return zero, let's say. I should use a while loop instead. While I is in I is zero, while I is smaller than x. So x should be zero, right? So if it's given zero, then the square root of zero is also zero. So while I is zero, which would be just false. Okay, so if x equals zero, then you just return zero, and um, then we can start at one. While I so let's say if I give it four, then one times one is one is smaller than four, so it should continue. Then plus xi, right? And let's say it becomes two, then two times two is, so this should be equals, then this should return two, right? Why is this so fucking weird? Um, let's try. If it's bigger, right? Something like that. Okay, so what is hint number two? Use a sorted property of integers to reduce the search space. Is this it? Let's try. Sign integer overflow. Okay. So if I do long here, would that work? Okay. I got it, but is this good? Okay, so runtime, I kind of fucked up. I did get it, but is it good? Yeah, let's check out the solutions. Like repeatedly subtracting numbers until we reach zero. Right. Okay, the while loop is doing something right. Okay, sure. We use a while loop to repeatedly divide the search range in half to find the square root. In each iteration of the loop, we calculate the middle value using the formula start plus n minus start divided by 2. Okay, yeah. The fuck? Middle point? In the middle is smaller than x. Ah, I see. Okay, that's kind of smart actually. So I go int start equals int start 1 int end x and then int mid stay random value. And then while start is this and mid what equals to start plus n minus start divided by 2, right? Okay. And then if mid times mid is equals to x, then you return mid. And if it's not, if mid if mid times mid is smaller than x, that means the correct answer uh is within the lower bound, is within start and mid, right? It's between start and mid. So end will equals to mid, right? And also if mid times mid is larger than x, then start will become mid, right? Wait, what? If that is if that squared is larger than x, oh no. This is n, and then just no. If it's if mid times mid is smaller than x, so the mid should be larger. Meaning, so the start equals to mid doesn't actually make sense, right? Does that not make sense? Wait, what? Mid equal to right minus left. Oh, moment, to be honest. Um, Yoke I go x, right? It means if mid times mid is larger than x, that means mid is too big. Oh, then I move the n to mid minus one. Okay. And if it's too small, then I move the start to mid plus one. Right. Okay, right. Okay. The loop ends when start becomes greater than end, and end is the integer value of the square. However, since we want to be using integer divisions, we round the value of n to the nearest integer to get the correct square root. Okay, like that. Oh, oops. Let's try. Okay, static path, pass it to an int, and what? Okay, so all of these have to be long. Do that. Runtime is very well, but the memory is not that good. So what happens here? What happens here? Keep finding the middle point. Oh, it's still too small. Now it's going to be too big. Okay, right. Okay, makes sense. Makes sense. Okay, that's it. That is today's video. Goodbye. See you tomorrow.